Okay, so what is being passed out to you right now is today's assignment. It is more practice on combining vectors head to tail. We will not be adding any more content to this next unit. The content has already been covered, so we will simply be practicing combining vectors head to tail and combining vectors by method of component, and then solving for components when given a resultant vector. The three things that we've already done. You will be tested over that next Thursday and Friday. For y'all, it'll be next Thursday, so the day before your Thanksgiving break. I'm going to be gone from school Thursday, Friday, and Monday, so I will not see you on Friday. When you're here, you'll have a substitute, and there will be a video for you to watch where basically I'm going to give you instructions on completing an assignment. So, yeah, and you're expected to complete it just as if I was here. So I'm going to go through this, and I'm taping the video for tomorrow's classes, so here we go. All right, so you got a paper that says combining vectors head to tail. If you have forgotten how to do this, again, I've already suggested you go to YouTube and watch the videos. Or at the very least, the instructions on this method is given for you in print on the first page of this handout. So that's what you're looking at right now, is the instructions on how to combine videos head to tail, or how to combine vectors head to tail. And then this nice little vector map right here. And the first thing that it tells you to do for practice is it went ahead and combined these vectors head to tail. So if you look here, there's a whole bunch of vectors. The home base starts here, and then the first vector goes here, then the second vector, third vector, fourth, fifth, sixth, seventh, eighth, ninth, 10th, 11th, 12th, 13th, 14th, 15th, 16th, 17th. It combined 18 vectors. So the first page asks you to do just one thing. It says to draw the resultant vector starting at the start and ending at the end. And then you take your pencil, you put it on the home base, and you use a straight edge. So I'm going to use my shape maker and my arrow creator, and you just draw the line that starts at the start and ends at the end. And that's your resultant vector. Always, 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 that's going to be your resultant vector. I've done it in red for you. And then it says to take your protractor and your ruler and measure the magnitude. That's the size of the line. And you're going to measure this one in centimeters. And then your protractor and measure the direction. So you're going to measure the size and the direction. And obviously mine is bigger than yours, so the size of mine won't line up with the size of yours. But I've got one here in front of me, so I will quickly take my ruler and set it on the line that I just drew and measure, and I get a number, and I'm going to report it like this. I'm going to report R for resultant vector with a little arrow over top of it, and then I'm going to report the magnitude. I got 11 centimeters. And then I'm going to put a little @ symbol, and then I'm going to use my protractor, and I have one of these cool 360-degree protractors, which I still have some for you to purchase if you are so inclined. And then I'm going to measure the angle of this line that I just drew. And I can already tell that this line is going to be in, based on the axes that I know, this is first quadrant, second quadrant, this is third. It's going to be in fourth quadrant. So I'm expecting somewhere between 270 and 360 degrees. And so I set mine, making sure that 90 goes up, making sure that my protractor is orientated correctly, and all that kind of good stuff, just like we taught you. And I get a line of about 310 degrees. And so I put it at 310 degrees. And that's basically what you're going to do for the rest of this assignment. You're going to draw vectors, you're going to combine the vectors, and then you're going to draw the resultant vector, and then you're going to measure the magnitude and the direction of the resultant vector. So Here's an example for each one of you on the first page. So you open up to the first page, and here's an example for you. So follow along as I explain the example. So the first step number 1, is to create a scale. We did this on your notes. A scale is something that takes the numbers that they give you. So here's the vectors that they give you. They give you a vector that is 3.0 meters per second and another vector that is 5 meters per second. And I need to convert that number into some amount of centimeters, which will fit on my paper in the boxes that I have given you. And you can see those boxes are fairly small. They are only about, they're 8 centimeters tall. So you need to keep these lines less than 8 centimeters, or else they won't fit in the box. So probably you're talking 6 centimeters. So some kind of scale that when I divide these by the scale, it will reduce it. And these, I've got 3 and 5, so it's easy enough just to use a 1-to-1 ratio. So we created a scale that's 1 centimeter equals 1 meter per second. So that way when I take these and I divide them by 1 meter per second, the units cancel out and I end up with some amount of centimeters. And that I can use my ruler to measure the size of the line. So the scale gets you the magnitude, the size of the line. How big in your ruler in centimeters that you're going to measure each line. So that's the first thing I got to do, is create the scale. Once I get the scale created, I know what size each line is. So this first line right here is going to be 3 centimeters long, right? It's going to be 3 centimeters long. And the angle that it's going to be at is given to me right there, 45 degrees. So all I have to do is take my protractor, and you have grid lines that are given to you. So you know how, you don't even have to worry about how to orientate your protractor, because you have a grid line that's given to you. Just make sure that 90 is up. Right? So you put your protractor right on the grid line that's given to you. Line up the grid line of the protractor with the grid line that's given to you, and then see where your angle goes. And if you measure this first angle with your protractor, you should see that it goes through the 45 degree mark on your protractor. So you should measure it. So here's the easiest way to draw them, because this one's already there for you, but you're going to have to draw this. The easiest way to draw them is once you set it down, take your pencil and some place above the 45 degree mark on your protractor, just put a dot. That's a reference dot. That's just a place for you to line your ruler up with. So that way when you put your ruler down, you can line it up with the crosshairs and the dot, and then draw the size of your line, however big it needs to be, using the straight edge of your ruler. Does that make sense? So you're just creating a little guideline. 2 dots. The crosshairs is 1 dot. The dots that you put there is the other. That'll give you the proper angle to create your line. And then you just create that line whatever size you need based on this one would be 3 centimeters. So my line is obviously much bigger than 3 centimeters because we're amplifying it so you can see that. But yours on your paper should be 3 centimeters long. And if I set my ruler down next to it, sure enough, it is 3 centimeters long. And then the second one is over here. So this is the first line. This one is matched up with this one. This one here is this line right there. And it should be at an angle of 135 degrees. So if I put my protractor right here, it should be over there and it should cross 135 degrees. And obviously mine's bigger than 5 centimeters, but yours will be 5 centimeters because I will take this number divided by this scale, and this line would be 5 centimeters long at 135 degrees. So all I've done here is on these first two crosshairs, you draw each individual vector separately by itself. You got that? Does that make sense? Yep. Okay. Then this third crosshairs over here is where you combine the 2 lines. So you're going to take and you're going to have to redraw each line, but this time you're going to start the second one wherever the first one ends. So you're going to combine them head to tail. Right? So you will draw the first one. So that's what I've done right here. This is the first line. So this I redrew right there. And then instead of going back to this crosshairs to draw the second line, I start the second line at the end of the first line. I start the tail of the second line, the tail is the starting point, at the head of the first line, head to tail. So I come up here and line up my crosshairs, and this one's at the 135 degrees. So then I draw this line right there, connecting them head to tail. And then once I got those two lines connected head to tail, all I have left to do is draw my resultant vector, and this thing is getting really busy, so I'll erase all that. And then I draw my resultant vector, and my resultant vector is just exactly like this one. It starts at the beginning and ends at the end. If you have two lines, it just starts here at the beginning and ends at the end. If there's three lines, then it'll start at the beginning of the first line and end at the end of the last line. It's the shortcut. All right? I'm going to show you one more. This one you should do as I do it, because you have this one on your paper. This is number 2 on your paper. Number 1 was the example. So this is number 2. So at the very least, you'll have 2 of them before this video is over. All right, so the first thing I have to do is create a scale. This one, very much like the last one, here's the 2 vectors that it gives me that I have to combine. I have to combine a 5 meter per second at 45 degrees with a 2 meter per second at 180 degrees. So the magnitude of those is 5 and 2. If I divide each one of those by 1, I'm going to get a 5 centimeter line and a 2 centimeter line. That'll fit on my paper, so that seems like an appropriate scale. So I'm going to say 1 centimeter. This is the size, the unit that I'm going to measure in, centimeters, is equal to 1, and this is where the unit that you're converting from goes. So this one happens to be a 1-to-1. But they're not all going to be 1-to-1. The very next question you're going to see, you're not going to be able to use 1-to-1 because you're going to be able to fit the line on the paper. So it has to be some kind of divider that will fit the line on the paper. This one works out good, and it will create the line that goes here at 5 centimeters, and the line that goes here will be 2 centimeters. So what I'm going to do now is I'm going to go to my my line, my crosshairs right here, set my protractor down on that crosshair. I'll put a little dot at the 45 degree mark, so that's my guide dot, right? Put it out here somewhere above 45, and then get my ruler and use it as a straight edge, and I will measure 5 centimeters on my ruler. I'm going to make mine bigger than 5 centimeters so that y'all can see it. But imagine, if you will, that that's 5 centimeters. You will draw yours 5 centimeters. Mine's bigger than 5 centimeters, so you can see that. But you will draw yours 5 centimeters using your ruler at 45 degrees. The 45 degrees is from your protractor, 5 centimeters from your ruler. Then the second one goes here. The second one is 2 divided by the 1, so it's going to be 2 centimeters long, and it's at 180 degrees. 180 degrees, if you set your protractor down, is directly that way. It's directly east. So if you set it down, actually, I'm sorry, directly west. You would come over here at 180 degrees, and you would put a little dot. Same process, just follow the same process every time. Put a little dot for your guide. Get your ruler out. Measure 2 centimeters. And draw your line, and again, I'm going to draw mine a little bit bigger than that 2 centimeters so you can see it. And this is 2 centimeters because it matches up with this vector. So now I've got the 2 individual vectors drawn. Now I'm going to come over here to this third set of crosshairs, and I'm going to draw these 2 vectors connected to each other, head to tail method. So I don't care which one you draw first, because if I draw this one first and then that one, they're going to end up being exactly in the same spot. And if you don't believe me, try it. But I'm going to go ahead and just draw the 5 centimeter one. No, I'm going to draw the 2 centimeter one first, because if I draw the 5 centimeter one, no, it should be all right. I'll draw the 5 centimeter one, and I'm just going to kind of freehand it a little bit here. And then where the 5 centimeter one ends, the 2 centimeter one starts. Go away. And then I connect this, and I draw the 2 centimeter one across this way. And those are my 2 vectors connected again. Head of the first one, tail of the second one. And then I draw my resultant vector, which starts at the start, ends at the end. And then I get my ruler out, measure the magnitude in centimeters, my protractor, measure the degrees, so measure the direction in degrees, and I report that. And this particular one, I got a 4 centimeter line when I measured that, and I got 66 degrees. So I would report my resultant vector up here at 4.0, convert it back into the units that you started with. So before meters per second, use my @ symbol, and it would be 66 degrees. Again, this comes from your ruler, this came from your protractor. From your ruler. You measure 4 centimeters on your ruler. It's the size of the line from your ruler. And then this is the angle that the line is pointing towards from your protractor. Okay, one more. I'm just going to do the scale for this one just to show you an example of a scale that is not 1-to-1, since the last 2 scales were 1-to-1. Because this one here, the magnitude is 60 meters per second squared, and this magnitude is 20 meters per second squared. So obviously if I used a 1-to-1 ratio there, I'd have to have a 60 centimeter line and a 20 centimeter line. I can't fit 60 centimeters and 20 centimeters in that little space, so I need to divide that by some number that's bigger than just 1. And since I could do 10, but then I'd end up with 6 and 20, or 6 and 2, and 6 is going to be tight. 6 is going to be tight. But 20 divides into that, makes 1, divides into this, makes 3. Nice and small line. So keep your line small. Try like go for under 5 centimeters, and I think I've created all of these so that they will be like under 5 centimeters, so you don't have to draw long lines, because when you do, then you end up lines off the paper and they don't match and they don't connect nicely. And so I think that I've done a pretty good job of making sure that all your scales can be reduced so that your lines are less than 5 centimeters long, so that they'll all fit on your paper nicely. It may be that some of them will need to be drawn in this middle one, the ones that go that way. Don't start those over here, because you could put either one. These don't have to be right to left. This one can go over here. This one can go over here, as long as when you combine them, they're on this grid. But as far as which one of these goes and which one of these, I don't care. It's whichever one fits best. So for this one, I would go ahead and create a scale that's 1 centimeter equals 20, and then meters per second squared. And then I would just divide 20 by that, and so I would create this line, and just for fun of it, I'm going to put that line over here now. So I'm going to create this line, 3 centimeters long at 25 degrees, so it's going to be somewhere like over here. I didn't measure anything, and it's going to be 3 centimeters long, because it's going to be 60 divided by 20, so that would be 3 centimeters long. And then this one would be 1 centimeter long, and it'd be at 90 degrees. That one, I know what that is, because that's straight up, but that's not 1 centimeter. Obviously, that's way much bigger than 1 centimeter. And again, that's also not 1 centimeter, but this would be 1 centimeter long. So that's how you do it. Then you just combine them over here, draw your resultant, measure the magnitude and the direction of your resultant. Everybody got it? All right, you should be able to get this done. There's only 7 more that you have to do, and I did half of this one for you already. So really you have 6.5 to get done. And then you'll be getting another handout with some component practice. All right. Good luck, and I'll see you when I get back.